So, Pius and Milda did a great introduction, I think, of like the big picture stuff, sort of. And what I'll be looking into is like very specific things. So I'll be trying to, well, first of all, a question. How many people here are familiar and like use or used Node.js? Okay, so that's great, because it's going to be relevant to you, and it's going to also be relevant to the rest of the people who I assume are Java developers. So my name is Laurynas, by the way. Laurynas Lubys. I'm a backend developer at Wix. And yeah, so the agenda for today, I'll refresh a bit on the Interop 101 as it pertains to calling JVM libraries from Node, because what Milda showed was the other way around. Your main program is Java, and you want to call something that's written in JavaScript. I'll be talking the other way around, where your main program is written in Node, in JavaScript, and you want to call something that's written in Java. And so for the sake of an example, we'll try using an implementation of Bcrypt that's written in Java, Bcrypt specifically. Then we'll try maybe consuming RabbitMQ messages, and then we'll get to the hacks to make this all work. These libraries I just chose, well, because we need some libraries to use, and Bcrypt is a good example because it's by design computationally heavy, and RabbitMQ is interesting because it's asynchronous. So that's that. So let's get started. So Interop 101. So the documentation for Java Interop and the whole GraalJS project. So there's GraalVM, which is the bundle, and there's the GraalJS, which is the part that deals with the JavaScript implementation and the Node.js runtime. So I encourage you to go read these docs if you're interested in this. Also, the GraalJS GitHub repository issue tracker is also a great repository. The people there are really responsive and answer the questions really well. And but I don't expect you to read it now. So what's the short of it with regards to Node.js? So GraalVM ships with a drop-in replacement for Node.js. You get a binary of like the npm binary, the node binary. You just put it on your path, and you're off to the races. It's mostly compatible with existing libs. Actually, I haven't seen any like places where they said it's not compatible, but they have a compatibility checker online where you can put in a package name, and they'll tell you if it's compatible with Graal or not. Yeah, if you want to enable the JVM interoperability and the polyglot mode, you enable it with the --JVM flag. And someone asked this question. So when going through the seamless boundary, which is an oxymoron, I guess. So when going through this seamless boundary, like all number types coming from Java are converted into native JavaScript doubles or floats or whatever they are in between things. And yeah, so strings are also, well, they have a different API, but they're represented the same, I think. Pretty much everything else on the Node side, you just get a reference to the Java object, and you can invoke Java methods on it. Yeah, also like a nice exception there is functions. So if you have a Java method that expects a single method interface, and if you give it a JavaScript function that has the same arity, it will actually accept it and execute it, so which is nice. And JavaScript objects on the JVM side. So yeah, they're also, like if you have a method that requires an int, and you give it the number 5 from JavaScript, which is not actually an integer 5, it will get converted to the integer 5. And if you want to just access plain if you want to access values of a JavaScript object, you can get a, well, your method, if your method accepts a map of string to object, you can get the properties by name that way. So, yeah, I won't be doing live coding here because I also have a B button which duplicates itself. So here we have the, so this is JavaScript first of all, just in case any of you are wondering. And the only thing that's odd about it is this thing, which is actually the way you access the way you access JVM functionality from Node.js. So Java.type is pretty much just just import and then the thing that's on the right side. So I do Java.type Java-lang system that imports the system class, and I can access its static member to print line hello world. And this is the way you would have to call it to make it work like that. And you would get hello world. So by the way, all the code that you'll see here, I'll put a link at the end of the at the end of the presentation to the GitHub repo where you can see it and play around with it. So okay, that's all good. I guess we can just start trying to use Bcrypt. So just a refresher, I don't suggest you read it. Bcrypt is a hashing function with a knob you can turn to change the computational resources needed to calculate the hash so that it's harder to brute force. So it's a hashing function that's by design hard to calculate. And yeah, the reason for that is so you don't get brute forcing attacks. Like this is just a synthetic example. Node.js has perfectly fine and actually faster implementations of the Bcrypt algorithm, which are native. But yeah, so let's just say that it's Bcrypt, but it's a stand-in for some custom authorization library, authentication library that you have in your enterprise. So our goal is to use the JVM JBcrypt library from Node.js, and we want to integrate it into our server to handle user logins. So the plan for that would be, first, we need to somehow tell the JVM where to find the jar. So for that, we use the command line argument, which is --jvm.cp, which CP stands for class path, and you put your regular Java class path there. So step 2, call this function from Node, just so that we can see that it works. Step 3, integrate it into our application, and then step 4, we can get to go home early because we did everything. So the first issue we sort of run into is tell the JVM where to find the jar. So, well, there are two ways you can actually specify to specify the class path for the application. One is, well, at startup with the command line argument. You can also add it at runtime. But why I'm saying that there's many options and none of them are great is that NPM and the JVM have different packaging, different ideas about packaging and multiple versions of the same dependency. So if you had, if you just went all out and you had like a bunch of, 5 NPM modules wrapping JVM libraries, and if you bundled all your transitive dependencies with those NPM libraries, you would probably get a class path conflict, and you would get method not found at runtime, which is always fun. So, yeah, I guess the takeaway there is that if you have, if you know how fun NPM module hell can be, well, you can also now add class path hell to that, so you get 2 hells at the same time. For the sake of this presentation, what we'll do, and you can see this in the code, which I'll hopefully add a link somewhere, we'll dump the class path from Maven and feed it to the jvm.cp argument. I won't show the output of that, but it's not too many dependencies, but just so that we can also at the same time build Java code and Node code, and use dependencies. So how we would use this Bcrypt library? It's actually exactly the same as we would use the system class, because it's also a static method, so it's more straightforward. The salt is just the format the salt has to be in. The flags you would run this with are here. So you need to tell Node to enable JVM interoperability, and you need to tell where to find all the jars that are needed on the class path. So this assumes that you're running the script from the same folder that the script is in. And we would get the hashed thing in the output. Which now I see is probably wrong because it's the same as the salt. Never mind that. So yeah, we called the library. Now we can just put it into our express router, right? So let's say we have two endpoints. One of them is the one that gets used the most. It's just get slash, and it responds with welcome. And another one is where you post your password, and for some reason you get your hash back, which no one does it like that, but that's the way it works here. So yeah, let's try to run it. Oops. Okay, so here I have, just run start. One thing that you'll notice if you're a Node developer is that it does not start up quickly. It really takes its time. Okay, so it started, it's listening. Here we're running a benchmark, and the benchmark is calling the slash controller, which just echoes welcome, and we see we get 200 requests per second, which is not amazing. Like the native Node implementation can do probably like 20,000, 15,000. So what gives? So I'll continue talking because I'll get to my point that way. One thing that the Graal developers mention a lot is that you have to let your application warm up. And now it finally warmed up. But it took a while and quite a few requests to actually start serving at a reasonable rate. So yeah, we deployed it to production, everything's great. And now the people start logging in. So let's say a person tries to log in every half a second. So you can see we have like 5,000 requests per second. And yeah, it dipped a bit, but yeah, we have now a bit less requests per second, right? It's 45 something. Okay, more people start logging in. And yeah, our requests per second fall even more. And what if, and notice that that one does not include like logins. It's just people getting the homepage. And if we have just one user who's continually trying to log in, what we get is we get a drastic drop in the requests per second. So, I'll just stop this. So, yeah, I actually spoiled the surprise. Yeah, we're not going home early. Yeah, as probably, since there are a lot of Node.js developers here, you probably know that what we did, looking at that code, is that we blocked the event loop, which is a big no-no, because in Node.js you just have, by default, you just have one thread that's handling all your application, and if it's blocked, nothing happens on your application. So yeah, fortunately the Node community knows how to deal with blocking workloads like this. You can create a pool of workers, and you just communicate asynchronously with this pool of workers, and this pool of workers can block all at once. So yeah, let's say problem solved for now. I mean, it's kind of not nice, but we can deal with it. So next up, we'll try to use RabbitMQ, which is a message queue. And yeah, the goal would be to consume messages from RabbitMQ. We want to use the RabbitMQ push API, which means that the RabbitMQ client calls your code when it gets a new message. The reason we want to do that instead of using the pull-based API, where you ask the RabbitMQ server to give you any messages, is for kind of the same reasons that last thing did not work out so well, because like if you're polling, well, you can block, and you don't want to block. And with like polling the message loop, the message queue, you might not want to have like a bunch of workers doing that. So the plan would be figure out how to do callbacks. I mentioned a bit that it should be straightforward. We'll figure out the Java API for the RabbitMQ client. And then we'll implement a callback in Node. And finally, we'll get to handle a RabbitMQ message in Node.js. So callbacks, as I mentioned, Graal nicely allows you to just, yeah, so this is just Java code pretty much. Well, it's Java code. I mean, you get the array list type, you instantiate it, you add a couple of items, and there's a for each method on the list, which allows you to give it a lambda, and it executes it. This is sort of related to the question someone asked there, but this for each method is actually implemented on the Java list and not on the JVM side, I think. Actually, I'm now really confused, but it does work like that. I got a bit confused now. Yeah. So moving on to RabbitMQ. Yeah, I don't expect you to read this because it's good old Java APIs. Things that are sort of note, the way this works: you create a connection factory, you configure it, you create a connection, you create a channel on a connection, which is an abstraction on a connection, which is basically just a connection. You declare a queue. You declare your callbacks you want called, and then you say channel, basic consume, queue name, auto acknowledge, then your deliver callback and your cancel callback, and then you say listening for messages on, blah, blah. So it's actually quite nice that doing this in Java JavaScript looks pretty much, well, the same. So there is some junk there, which is like also a nice example of how you would extend or implement the Java interface in Node.js, which is an interesting example, but we won't really stick around with that. Yeah, so you create a connection, you configure a connection factory, you configure it, you create a new connection, create a channel. Of course, we're kind of blocking here and here, which is not nice. You declare the queue. I have no idea what those arguments do. Probably something. Yeah, you declare your deliver callback, your cancel callback. So deliver callback is the callback that will get the message once it's delivered. And yeah, you say consume and log that you're listening for messages, and this is just a hack so that the event loop doesn't exit because it doesn't know that it has to do anything. Because Node.js exits once there's nothing on the event queue and there's no outstanding stuff to do, so it will just figure out that at this point it's just safe to exit because there's nothing happening. So yeah, this is just another comparison. If we just remove all the ceremony and craft, that it's basically just the same code, right? Same ugly code. So let's see how this works. Right, so let's start our, so this is pretty much the code that's written there. You can also, you'll be able to find this in the repository that I'll link to. Okay, so now we have that we're listening for messages on hello rabbit, and we'll use RabbitMQ admin to publish a message on that queue. Oops. Okay, that's not. Okay, no, actually I know it. But it's actually a big issue. Multi-threaded access requested by thread blah blah, but is not allowed for language.js. Which, when you think about it, makes perfect sense, because like, JavaScript has no synchronization primitives. Like if you just, modified something inside something that Node.js can access while it's running and doing something else, you have no idea what would happen, and you would probably run into a really inconsistent state and would have a really bad time. So yeah, we can't call JavaScript from another thread, which is not great. And you can actually find references and discussions about this in the GitHub issues for the GraalJS project. So does this mean that no event handlers written in Node.js, no using async Java.io, and just in general, async Java libraries, that return promises and stuff, no reactive streams coming from the JVM side into Node. So yeah, now we get to the hacks part, and before we get to that, I just want to mention again the things we discussed again right now, just in case you fall asleep or just can't take it anymore after the next section, that dependency management is not solved, but I mean, it's hard, but you just have to figure something out. It's kind of straightforward. Calling synchronous code from Node is simple. Well, as you saw, like if it's a static function, it's just you get a function in JavaScript, which is amazing actually, except that it doesn't really work that well with the Node.js event loop model. And calling asynchronous Java code from Node.js is not solved. So now we get to the hacks. Because what if we really want to call asynchronous code from, well, what if we really want to do that? So we want something like this, right? You can see there's these question marks. So let's just live for a while in magic la la land, and let's just say that exists some library, something that defines a function bind callback, which what it does, it allows you to give it, so you call this bind callback with a JavaScript function. It returns to you a Java function that you can give to Java code, and that can later on be executed safely on another thread. And the Java side can also get the result from this computation, right? That would be like amazing. So yeah, if we use this function here, what we would expect to see is let's wait now, because like everything happened, but this will happen asynchronously later. Then something async, which is just a thing that it's just a Java class that calls the function that you give it sometime later. So, and it will send the value hello from JVM. So what we expect to see, let's wait now, then we would expect to see this console log, and then once we resolve this promise 100 milliseconds later, we would expect the JVM to also log hey, because that's what came back there. So unfortunately, fortunately, GraalJS does not provide anything like that out of the box. But let's just see, maybe we can do something about that. And this is like I'm not sure if it's a good idea to do this in production, but I guess you could, and it might work. So, and don't worry, if this is scary, it will get much worse. So in order to solve this problem, you sort of need three components. One is the interop bus, which implements the magical bind callback function. You need one queue of pending thunks and one queue of ready thunks. You need a Node.js worker thread, which is the worker thread module in Node, which is kind of disposable, and you can block on it, which reads from one row, one queue, and puts it into the other, and it can communicate with the main node process via messaging. And you have a message handler on the parent process. So what we want to do is we have this purple triangle representing a JavaScript callback that we want to execute. And so we call the interrupt bus's method bind callback, and we give it this callback, right? This guy, interrupt bus, then returns back to you a bound function which contains a reference to that original callback that we want to get called later. So now the JavaScript code can give this bound function to some asynchronous Java code, which is we actually wanted to like invoke with this thing, but we can't because it's that we got the error back there because it's in a different thread. So this asynchronous Java code does something, and then it produces a result. So the green thing, so like in Node, you usually have this interface where callbacks accept the first argument an error, and the second argument a successful result. So we'll use the same pattern of passing both of them. So this bound function actually accepts these two arguments. The synchronous Java code calls this function, and when it calls this function, instead of executing the callback directly, what it does is it, first of all, it creates a promise and gives it back to the Java code, and it also wraps the callback, the arguments, the error argument, the success argument, and the promise into a thunk and puts it on the pending queue. So once it gets put on the pending queue, the Node.js worker, which is blocking on this queue, gets this thunk, puts it into the ready queue, and also notifies the main process that there's a thunk that is ready to be executed, to be evaluated. So on this message, the main node process wakes up, and it then goes to the ready queue. It doesn't need to block because it already knows that there's a thunk there, and it doesn't need to block at all because, well, even if there's nothing there, it will just not pick anything up, but it will pick it up because it was first. So now in the main process, you can finally take this thunk, take out the callback you wanted to get called, take out the error and the success argument, evaluate this function, and complete the promise. So any questions? I guess this is very clear. So yeah, back to RabbitMQ. So we implemented this bound.js callback that we call. It's just an alias for a function that takes two arguments, one of which is like a generic argument. The second is a throwable, and it returns a completable stage, or well, a future of the second type argument. So it's actually pure lies because it's only for Java. Only Java believes that those types are like that. On the Node side, you can put in whatever you want there. And it's gonna crash badly. Actually, that's a really fun experience, funny story. I saw, well, but not on this version, but on the previous one, when playing around with this, I actually had a seg fault. So that's fun with stuff like this. Yeah, so if we remember that previous example, so now we have this magical bind callback function. We have this, so yeah, yes, so this adapter is needed just so that we adapt to the API that the RabbitMQ client expects. And it cannot be in JS because you can't execute JS on another thread. And yeah, the changes we need to do here are minimal. We just need to call this JS delivery, well, instantiate this adapter and give it this bound callback. And hopefully we can see how it works. So this is actually really, really a lot of effort for a really not impressive take 2. Okay. So, again, not super fast at starting up here, listening for messages, and hello Node, yay, yay, woo! Yeah, I mean, it works. I can even send another one. I can send, like, maybe someone wants some message sent? No? Well, okay, let's leave it at that. So, yeah, coming back to the takeaway points, dependency management is not solved, and yeah, you have impedance mismatch there. Calling synchronous code from Node.js is simple, but blocks the event loop, which is bad. And calling asynchronous Java code from Node is not solved, but you can hack something together to make it work for yourself if you're feeling brave. Yeah, and that's all I had. This is the link where all that thing I talked about is implemented. It's a naive implementation. We actually, well, we worked on a more mature one, but just for getting the point across, it's like the bare minimum components you need there. So yeah, thank you.